our last finalist, finalist number 4. He grew up in South Korea, but he visited Boston as a teenager, and he visited MIT, and he decided then and there that he wanted to come back to MIT as a graduate student, and so he has. He's a graduate student in the chemistry department, where he's engineering new ways to induce strong interactions between beams of light, and that has applications in quantum computing. And you'll see in a moment, he's also quite a Star Wars fan. Put your hands together to welcome Joseph Yoon to the stage.
This is my favorite scene from Star Wars, the lightsaber duel. I always wanted to have a real lightsaber like this and wondered how to make one. Today, I'd like to tell you how to make a lightsaber using quantum properties of light. So let's first take a look into the properties of lightsabers. First, a lightsaber must be able to cut through materials, like trees in this movie. How can you achieve this in real world? Well, a powerful laser beam can already cut through steel, like a razor blade or a saw blade. So we can achieve this. Second, a lightsaber has a finite length. Normally, if you shine laser beam, it just propagates forever. But if you use 2 mirrors to trap light, you can do this. However, the third one is tricky. Lightsabers, they clash, they repel each other. But light normally doesn't do this. This is because normally light beams pass through each other. So in principle, we cannot make a lightsaber. However, quantum physicists have figured out a way to make light beams repel each other. So we've put a single atom between 2 mirrors and then turn this lightsaber on so that this atom gets excited and becomes larger. And then we've prepared another one, lightsaber 2, and then surprisingly, these 2 repel each other. So we can go back to the list and check this off. So we can effectively make a lightsaber in a lab, but we don't want to use it to battle our enemies. So we think it will be useful in another way. So we are taking it one step further to have one control the other. If we cross the 2 lightsabers and turn the lightsaber 1 on, then the second one cannot be turned on. Or if the first one is off, then the second one works again. This means that lightsaber 1 can switch the lightsaber 2 on or off. And this can be used to make a computer, because computers are made of millions of electrical switches that can be turned on or off. But the problem is, this is very inefficient. When electrons go through wires, they generate heat, and that's why our computers get hot. On the other hand, light switches, they are much faster, much cooler, and importantly, they are key elements of quantum computers. So it will allow us to solve problems that are out of reach today. So that's how quantum physicists are working hard to implement their lightsabers into quantum computer. Thank you very much.
Let's hear it for Joseph Yoon.